Hello everybody and welcome back to Galaxy Administrator Training. My name is Simon Gladman and I'm a bioinformatician at the University of Melbourne in Australia, and I'm also one of the administrators of Galaxy Australia, a large public Galaxy server. In this session, we'll be talking about running jobs remotely using Pulsar. So to start, I'd like everyone to go to our website, the training website, training.galaxyproject.org. You can see here we have Galaxy Server Administration, which is the location of all the tutorials that we've been using so far this week. If we click on that, down here, there is the tutorial running jobs and remote resources with Pulsar. And this is the one we're going to be doing in this session. So we click on the hands-on and it will open up that particular tutorial. This tutorial was written by Nate Karor, myself, Marius Vandenbeek, Helena Rasche, and Jinmaro Kikuru. Okay. Some of the questions we hope to answer in this tutorial are: how does Pulsar work? And how can I deploy it? And at the end of it, we'd hope you have an understanding of what Pulsar is and how it works, how to install and configure a RabbitMQ message queuing server, how to install and configure a Pulsar server on a remote Linux machine, and how to be able to get Galaxy to send jobs to that remote Pulsar server. Some of the requirements that we would like you to have done before are this list of tutorials here. We're definitely going to need Galaxy installed on a machine somewhere. Hopefully you've completed the Galaxy, connecting Galaxy to compute cluster, because we're going to need to work on the job conf file. Mapping jobs to destinations, because we're going to need to change the destination for some tools, and also reference data with CVMFS. And we also need a server or a virtual machine on which to deploy Pulsar. And if you go back to the list of machines here, which is the spreadsheet you would have been told about earlier in the week, hopefully you've claimed one of these virtual machines that you've installed Galaxy on. I've claimed one here, GAT2021. Your list will look a lot different. This is what we've set up for recording. You'll notice down here though, there's a second tab for Pulsar, because what we're going to do is we're going to have Galaxy running on one virtual machine and Pulsar running on a completely different virtual machine, and we're going to get them to talk to one another. So on the VMs tab, we have the machines listed for the Galaxy servers, and on the Pulsar tab, we have machines listed for Pulsar. You also look completely different to this. This is just what we've set up for recording this video. And you can see here that I've claimed a second virtual machine, which I'm going to install Pulsar on. Okay, getting back to the tutorial. Let's just give a quick background about what Pulsar actually is. So Pulsar's Galaxy Project's remote job running system. It was written by John Chilton of the Galaxy Project, who did an awesome job with it. It's actually a really cool piece of software. It's a Python server application that can accept jobs from a Galaxy server, and it can either run them itself or it can submit them to a local resource, the DRM like PBS Talk or Slurm or Condor, something like that. And it then monitors those jobs, collects up their results and sends them back to Galaxy for us. It's actually pretty cool. There's a lot of documentation on Pulsar that can be found at these locations. At the Galaxy end, Galaxy talks to Pulsar via these two job runners. And these are located, all configuration for this is located in the jobconf.xml. Okay, what are we going to actually try and do today? Well, the first thing we're going to do is install and configure a message queuing system. I'll talk about why in a minute. The second thing we're going to do is install Pulsar on our second virtual machine. The third thing we're going to do is we're going to configure Galaxy to talk to that Pulsar server. And the last thing we'll do is we'll test Galaxy by running a job or trying to run a job on that Pulsar server. And then we'll have a little bit of a chat about how to use Pulsar in production. Some more assumptions, which I've already talked about. One little thing is that this is not intended as a standalone Pulsar guide. This is intended to get you to configure Rabbit and Pulsar and Galaxy all to talk to one another. Okay, well, how does Pulsar actually work? Well, Pulsar is designed to run on a remote compute resource from your Galaxy server. So if this gray box here is your Galaxy server, and this gray box here is your remote compute resource, the idea is that we can get Galaxy to talk to this remote compute resource and get the remote compute resource to run jobs for us. This can be handy in lots and lots of situations. And the way it works is that Galaxy sends a message to the Rabbit MQ server. This server could be running on the Galaxy server or on a completely different machine. It sends a message to the particular queue that's been set up for a particular Pulsar server, and it says, "Hey, I've got a job that needs running." It will then monitor that status updates for that queue to see if the job's being run or not. The Pulsar server at the other end monitors the queue, and when a job appears, it will take control of it. The Pulsar server then downloads all the required files and the job metadata from the Galaxy server using curl into its local file system. The Pulsar server then looks at what tools it needs, and if it doesn't already have them installed, it will install them. It usually does that with Conda, but it can be done with Docker or Singularity as well. The Pulsar server then starts the job running using its local mechanism, wherever that's configured. It can either run it just on the local resource, or it can send it to a queue, a batch system like Slurm or Condor. And once the job's finished running, the Pulsar server then sends a message back to the queue saying, job's finished, I've got some files to send to you. And then Galaxy looks at the queue, says, yeah, okay, no worries, send me the files. And so Pulsar will then return the files back to the Galaxy system. And then the Galaxy server acknowledges that the job's complete and marks the job as complete in its own database. So it's kind of long and complicated and involved, but basically what happens is Galaxy says to the queue server, I've got a job. Pulsar recognizes the fact that there's a job available, runs the job, and then tells Galaxy that it's finished. Pretty simple. Just some notes. RabbitMQ uses the advanced message queuing protocol to communicate with both Galaxy server and the remote Pulsar VM. Transfer to files can occur via curl, but it can occur via other things as well. And there's a tip box here you can look at if you wish to see other types, but you can use SCP or rsync, or you can even use HTML file transfers. RabbitMQ is written in Erlang, and so that doesn't really add much overhead to the Galaxy VM. However, in larger installations, such as use Galaxy.star servers, most of us have generally installed the RabbitQ server on a separate machine. If you've watched the slideshow on Pulsar, if you haven't, I suggest that you go and do it. You'll remember that Pulsar can run in two different modes. It can run either as a REST API or run in message queuing mode. And the reason why we're using message queuing mode here and not RESTful is the fact that we don't have to open up the firewall on the remote machine. We can just have Pulsar itself ping the queue every now and then. Okay, so the first step in this tutorial is to install the message queue. So we need to have a message queuing server running on our Galaxy server. So we're going to do that in the first step. And obviously, as we're using Ansible to do everything, we're going to need a couple of Ansible roles. So the first thing we're going to do is we're going to open up our requirements.yaml file in our Ansible configuration, and we're going to add a couple of roles. We're going to add the RabbitMQ role, and we're also going to add Pulsar, because we'll need that later in the tutorial. We might as well just add it now. So I am opening a terminal. I'm going to SSH to my machine with the username Ubuntu. And this is my machine. Yours will be a different one, hopefully the one you've been using all week. Okay, so now I'm in my user directory. I have all of my Ansible stuff stored in the Galaxy folder, which is what the tutorial of the other tutorials have done. So CD Galaxy. And if you have a look in here, you can see all of the requisite things that I would have had for the rest of the Ansible tutorials, including my playbook, the group bars directory, the roles directory, templates and files directories, my requirements.yaml, the vault password, and my Ansible config, and importantly, my hosts file. All right. So if you're up to date with everything, this is what you should be looking at. If you haven't done any of the other tutorials, you won't have any of this stuff. And so you really need to go back and do the other tutorials first. Okay, so first thing we need to do is add the 2 new roles to our requirements.yaml file. So Vim or whatever editor you want to use. I like Vim. And we'll add in these 2 lines here. Save and close it. And now install those 2 roles using the Ansible Galaxy command. Okay, so you can see here it's downloading the RabbitMQ role, and it's also downloading the Pulsar role. So to check this and see if they've been installed, do a tree on roles. That's L1. If you haven't got tree installed, it's a really handy little utility for showing the diagrammatic representation of the directory structure. And you can just use sudo apt install tree if you're interested. But anyway, so you can see under roles here, we have now got Galaxy project.pulsar, and we also have use Galaxy EU RabbitMQ. All right, so if we have a look in use Galaxy RabbitMQ, you can see here it looks like a typical Ansible role, and there's a README. You can see here all about the README, some of the different things we need to configure. There's a few different things we need to talk about, which we'll go on and talk about in a minute. But yeah, the README is always handy to read. If you have a look in the tasks directory, you can see here there's a whole bunch of different things, including installation requirements for Debian and Red Hat, but yeah, also installing RabbitMQ plugins and configuring clusters of Rabbit servers, etc., how to configure users and vhosts, which will go on. But basically, everything that we need to do with Rabbit is defined within this role. And so by changing variables in our Ansible playbook, we can define how this role's run and which parts of Rabbit to install, etc., just like every other role that we've used so far in these tutorials. Right, going back up to here and going back to the tutorial. Okay, so RabbitMQ is a queue server. Basically what it does, it opens up some queues and allows various machines to talk to those queues, to pass messages backwards and forwards between one another. So Galaxy can send messages to the queue, Rabbit will store them for it, and then other machines can contact the same queue and look for messages that might be targeted at them. Now, we need to define the queues, or in Rabbit's case, they call them virtual hosts. And we also need to define users. We need to define which users are allowed to access that particular queue, because obviously we don't want machines that shouldn't be reading messages to be able to read them. So we need to put on some kind of security. And we do that within Rabbit by defining a virtual host and then assigning users to that particular virtual host. Okay, so the way we do that is we define a virtual host, and then we also define a user, and then we say, all right, this particular user can talk to a virtual host. And obviously you can see here that we need to set a password for that username. And it's a really good idea to make that password random and long and not store it within your GitHub repo unless you're putting it inside an encrypted vault, which is what we'll be doing in this tutorial. Okay, one thing about the configuration of the RabbitMQ server. So whatever virtual machine you have that is running Rabbit, it needs to have a particular port open in its firewall. So even though it's running on the same machine as the Galaxy server, and Galaxy can talk to it via localhost, which means it doesn't need to open a port in the firewall, the remote compute resource, i.e. our Pulsar server, will need to talk to this particular Rabbit server via the internet. And so we will need to have a port open in the firewall. Yeah, so 5671 is the default. Okay, we are going to need to set some passwords for our Rabbit server. So one, we need to set a password for the administrator user of the Rabbit server. The administrator user can do things like run diagnostics, add new virtual hosts, add new users, all those kind of things. So we need a password for that. And we also need a password for the virtual host that we're going to set up so that our Galaxy server has something to talk to. And so we're going to need to edit our vault, our encrypted vault, and add some passwords to it. So to do that, I'll just clear the screen. We're going to need to use the Ansible vault command with the edit subcommand. Ansible vault, edit, and our vault is in group var secret.yaml. So that's what it looks like if we open it with Ansible edit. Of course, if we open the same file just by looking at it, we get an AES-256 encrypted mess that we can't read. So we need to open it with Ansible Vault. Okay, we're going to add a couple of passwords to this. Vault RabbitMQ password for the vhost. So this is the particular password for our queue that we're going to create. So I'll copy and paste that. And I really don't want to use a really long password here because that's a stupid password to have. And so I'm going to go to a different website, generate password. And I'm going to create a password of length 16. And I'm not going to include symbols. And I'll generate a password, and here it is. It's always a good idea to generate random passwords for things. I'll paste that there. And then I'm going to generate another password for our administrator. Now this is one that if you ever want to administer the RabbitMQ password or RabbitMQ server, you're going to need this password. So sometimes a random string is not that great unless you repeatedly open the vault and copy out the password. But if you use a password manager like Bitwarden or something like that, it's a good idea to put that random string password into that. So I'll copy this. So this is, we're going to set the admin password for Rabbit here. And once again, I'll create another strong password. I'll dump that there. And obviously, if I was serious about this and using it in production, I would then copy it to my password manager. Okay, so I'm going to close this. And if we look again at this secrets file, you'll see that it's got a bit longer than it was before, but it's still heavily encrypted. All right. Okay, so we go back to the tutorial, and now we need to edit our group vars galaxy servers.yaml Ansible vars file. In that, we're going to add all the things that we need to install RabbitMQ on our Galaxy server. So remember, we're not actually telling Galaxy about it yet. All we're doing is installing it on the same virtual machine. And so we might as well put the configuration details for Rabbit into that file. So there's a few things we need to do. The first one is we need to tell CertBot about the fact that we're going to be running Rabbit, because Rabbit has needs a certificate. And we're also going to, every time we get a certificate for it, we're going to have restart the RabbitMQ server so that it knows about the new certificate. We're going to install 3.8.16 version of Rabbit because that's the one that is most compatible with the latest version of Erlang, and I'll talk more about that in a minute. We're going to add in the RabbitMQ management plugin, and then we need Rabbit to listen. So we need the Q server to be able to listen on localhost as well as listening on the internet. Now, when we're listening on localhost, it's just a simple TCP connection over localhost to port 5672, which is internal. But remember, we've opened into firewall port 5671, and we need to listen to that on the internet, but we want it to do it securely. So this is called an SSL listener. And then we need to set all the SSL options, like where to find the certificates and the keys and etc. Okay, the next part of the configuration is we need to set a virtual host, and we're going to call our queue Pulsar Galaxy_AU. And basically, this will just be a that's just the name of the queue that we're going to connect to and send messages to. Then we need to define a couple of users. We need to define the administrator user so that we can go back in and make changes to our RabbitMQ server if we need to in the future. And that user will be admin. The password we're going to grab out of that vault. We're going to tag it as the administrator, and we're going to set its virtual host to be the root, which is basically everything. And then we're going to create another user. The user is going to be Galaxy AU, and this is the user and password combination that Galaxy and the Pulsar server will use to communicate with the Rabbit server or the Q server. Right, so we'll create another user called Galaxy_AU, and we're going to let that user have access to the virtual host that we created before. And then, right, so let's make those changes. So go to group files, Galaxy servers, and here's all of our Galaxy configuration. As you can see, we've got quite a lot. Oops. If we go all the way to the top, actually, where is our RabbitMQ stuff? Our CertBot things, I mean. USB, Galaxy config, CertBot. Here we are, down the bottom. Okay, so you can see here we need to add CertBot share key users to the RabbitMQ server. So we just need to add that underneath that. And we need to add in this system CTL restart RabbitMQ server whenever we've changed the certificate. Okay, and then now that we've done that, now we need to add a whole bunch of configuration for the RabbitMQ. So we go to the bottom of our file, underneath all of the other stuff we have. RabbitMQ, and we'll cut and paste all of this stuff here in. Okay, so as I said before, this defines the version we want to install and any plugins we want. There are lots of RabbitMQ plugins, but the one we want is the management. It tells it how to go about listening and some security information. Okay, now we need to define the virtual hosts and the users. So we will cut and paste this section in. And as I've already talked about before, let's put a space in there, just make it easy to read. This defines the user, sorry, this defines the queue, the name of the queue we're going to create. And this defines a couple of users and lets them have access to those particular queues. Okay, so we're going to close that and save it. Now we're going to add the RabbitMQ role to our Galaxy playbook. And this will, then when we run the playbook, we'll install Rabbit for us. So let's do that. Galaxy YAML. Now you'll notice here, and this is really important, that RabbitMQ needs to come before Nginx and before CVMFS. So in our list of things here, after we install Galaxy and Miniconda, go into here, and we add in news Galaxy _eu RabbitMQ, and this needs to go here for a bunch of different reasons. But if we click on this box, it will explain to us why. There's kind of a circular dependency going on. So Nginx depends on Galaxy, SSL certificates depend on Nginx, RabbitMQ depends on SSL certificates, but Galaxy depends on Rabbit. So we kind of need to have Galaxy installed, but not tell Galaxy about Rabbit until Rabbit's installed. And then we can go back and tell Galaxy about Rabbit because of the way the dependency flows in a circular kind of fashion. So hence we're going to install Rabbit by itself, get it running, and then tell Galaxy about Rabbit. Otherwise, Galaxy will go looking for Rabbit, it won't exist, and then it'll crash, and we'll have lots of errors in our Ansible, and things won't work. But if we have all this stuff installed first, and then install Rabbit by itself without telling Galaxy about it, Rabbit will install nicely. And then the next time we run the playbook, we can safely tell Galaxy about Rabbit because it's installed. And there's a long explanation about why that is here. All right, so the next thing we need to do is save this file and run the playbook. And basically, we're just going to run this extra role. Save the file, close it. Ansible playbook, Galaxy.yaml. All right. So I'm sure you've seen this happen lots of times so far during the week. Nothing's going to change until we get down to the Rabbit section, and then I'll explain what's going on. While we're waiting for this to happen, there's a couple of things I need to talk about the relationship between RabbitMQ and Erlang. Rabbit is a queue message server written in a language called Erlang. Now, however, Erlang changes quite frequently and has non-backwards compatibility. And so certain versions of Rabbit are designed for certain versions of Erlang, and they won't work outside of those certain versions. The version we're installing will work on versions of Erlang 23 and 24, but won't work outside of those versions. The latest version of Erlang is version 24. So if you install this server on your production machine and you regularly run apt-get update, apt-get upgrade, or yum upgrade, etc., yum update, and you're regularly upgrading all the packages on your machines, occasionally Erlang may reinstall to a new version and it may break Rabbit. And so then you'll need to go back to our playbook and upgrade the version of Rabbit that you need to install. You can search for this information on the internet. I normally just go to Google and search for RabbitMQ Erlang version. As you can see, I do that quite a lot. And there's the first page that normally comes up. It says which version of Erlang is suitable. And I know this is small, but I'll make it a bit bigger. But basically, the version we've installed here is 3.8.16. and the minimum Erlang version and then the maximum Erlang version is listed. And so this will help you resolve any issues you may have. All right. So as you can see here, we've installed Erlang. And now we're at the point where we're installing Rabbit and setting the virtual hosts and the users, etc. And you can see here we've set the admin with the password and the user with the password. And now we're going through the rest of the playbook, and hopefully nothing will change. We just changed the post-renewal script for certbot, because we added in the fact that we need to restart Rabbit when that happens. And now it's up to CVMFS, which nothing should change. Slim, and we've finished. Okay, so now we've successfully installed Rabbit, and the way we make sure it's there and running is we use systemctl, and we just call up the status. Okay, and as you can see here, it's active, it's running, and we've started the RabbitMQ broker, which is fantastic. Okay, and there's a bit of information if you want documentation, stuff like that, and the location of the logs. So you can see here the log, my log is located here, and if I really wanted to, I could go and have a look at that log and see what's going on. And this is where it's getting its configuration from. Okay, now, even though this says that it's running, that's great and all, but sometimes it doesn't give us all of the information that we're after. And so we installed the Rabbit management software, and so we can run things like RabbitMQ diagnostics, and this will tell us if our queues are actually up and running. So let's go and have a look. Sudo RabbitMQ diagnostics status, and it gives us a whole bunch of information here about how much memory is being used, etc. How many virtual hosts? We've got 2, which is great. And then what interfaces it's listening on. So you can see it's listening on IP6 and IP4. It's listening internally on 5672, which is cool. That's what we want. And it's listening externally on 5671. Perfect. And it's using SSL to do that. All right, fantastic. So this doesn't necessarily mean that we can actually talk to it though. And so what we might want to do is run these curl commands just to check to make sure that it's running. So let's run the top one. We'll try and talk to it to 5672 via localhost. Okay, it's received, but it didn't like the HTTP protocol because it's expecting AMQP protocol, but that's okay. At least we know we can talk to it. And let's have a look at curl -k for the external one. And yep, it works as well. All right, and if this is a problem, then we do systemctl restart RabbitMQ. We can make sure the private key is in the right spot, and we need to make sure that the private key is shared correctly with the Rabbit user. All right, so now we have a queue server running on our Galaxy server. So if we go back up to this top part here, our little diagram, now basically we've installed this green box and we've configured a queue here for Pulsar. And we've got another queue that's for admins, but the one we're considering is this Pulsar queue, which we called Pulsar/Galaxy_AU. Okay, so now what we need to do is we need to think about our remote compute resource, and we're going to install Pulsar on it in MQ mode, and we're going to get it to talk to the queue. Okay, so this is the meat of this particular tutorial. Okay, so we're going to install and configure Pulsar on a remote machine. And if you remember, our Pulsar server is going to run on a remote machine, and we can get the name of that remote machine and our IP address for it and the etc. from this location. And then we need to tell our Ansible about that remote location. We also need to configure a new playbook for Pulsar. So that's what we're going to do now. Okay, we're going to use the Galaxy Project Pulsar Ansible role to do all this work for us. One of the things we really need to set, in fact, we do need to set, is where on that remote machine we're going to install Pulsar. And we're going to install to /mount on our remote machine. There's some bunch of other variables we can set, like where the virtual environment we're going to run Pulsar from is, where the configuration directory is, any optional dependencies we want to have installed. We're going to create Pulsar user if there isn't one already, and which user we want to have that runs Pulsar. Yeah. All right. So these are the for this particular Ansible role. These are some of the variables we can configure, but the one we do need to configure is the server directory. All right. So we're going to create a new group vars file, because this particular server is not our Galaxy server. And so we're going to want Ansible to talk to a different machine. And so we need a different group vars file for that, because we're going to create a new group in our hosts. So we need a new group vars file. And we're going to call this one Pulsar servers. Right. So let's do that. Let's clear the screen. And then PIM group vars, and we'll call it Pulsar servers.yaml. And in this file, we are going to add a bunch of stuff. Well, the first thing we need to tell Pulsar is, which Galaxy server are you responsible for? Or which Galaxy server is going to be sending you messages? And that's kind of important for us. And so we're going to copy these two lines in first. Copy that one. All right. And we can't just leave it blank. We need to actually give it the one. Now, I know what my Galaxy server is. It's GAT-8. So I'm going to put that all in here. GAT-8.os.training.galaxyproject.eu. And you need to put in your one. So we need to have the fully qualified domain name of the RabbitMQ server. All right, now we need to set some variables about where we're going to install Pulsar and whether we're going to use pip to install things, what SSL library we want to use for our communications. This one here sets the fact that we want to run start and stop Pulsar using systemd, and that we want to use the webless version of Pulsar. And I'll explain what that means in a minute. So let's just copy these bits in first. Oops, just these bits. We'll talk about them. Okay, so this is saying that we want to install Pulsar into /mount/Pulsar. This is saying that we want to use pip to install Pulsar, because Pulsar is a Python package. It's been packaged into PyPy, which means we can simply install it by doing pip install pulsar-app. We want to use the PyCurl SSL library, because we want to do all our file transfers by curl, and we need to tell curl about which SSL library to use, and we're going to use OpenSSL for that. We need to set the fact that we're going to start and stop Pulsar using systemd, and we're going to start the webless version of Pulsar using systemd, not systemd. Now, the webless version of Pulsar means that we're going to run this Pulsar server in message queuing mode. If we started it in paste mode, it would be the fact that we're going to run a web server using Python paste web server, and we're going to be listening for REST API requests. And that's the other method of running Pulsar, which we're not really going to go into here. Message queuing mode is much better. And there's some discussion above in the tutorial about why that is. So we need to say webless so that we know we're going to be running in message queuing mode. All right, let's look at some more things. All right, so this says we're going to create a user. We're going to create a user called Pulsar to run all the Pulsar things, and we'll give it a shell bash. So I'll copy and paste those in. And in our Pulsar role, there's some rules that say whether we're just going to use Ubuntu to run Pulsar, or whether we're going to create a new user and we use that to run Pulsar. Maybe it's not such a good idea to run Pulsar under Ubuntu. It has sudo and all those other kind of permissions, which means that weird things can happen to your remote compute. And in fact, if we just create a user here, we can and give it a shell, we'll get Pulsar to run underneath that user. Okay, so now we need to install some optional dependencies. Now, I'll go through all of these after we cut and paste them into our configuration. So copy and paste. Okay, so we need to install PyOpenSSL. And the reason for that is that we need to initiate transfers from Pulsar and be able to talk to Galaxy, and we need it to be encrypted. And so we're going to need the Python OpenSSL library. We're going to need PyCurl so that we can talk to Galaxy using the curl. And we need to install a drama library if we're connecting to something like Slurm, or we're connecting to Condor, etc. We need to install a drama library. We need to install Kombu, which is Python's Python bindings for AMQP things, message queuing behavior, and we need to install the AMQP, but we want to pin that to version 5.0.2 because 5.0.3 does some weird things that we haven't figured out yet, and we need to install psutil. Okay. Now, so our role will pick up these optional dependencies and will automatically install them for us. So that's really nicely written Ansible in our Pulsar role. Now we need to actually set all the YAML configuration for our Pulsar, which we're going to cut and paste. Okay. Now, this top part here sets a few different things. The first one is staging directory. Now, the staging directory is when Pulsar copies files from Galaxy to the local file system, it needs somewhere to put those files then to work on them. And so it will create job subdirectories or temporary job subdirectories underneath this staging directory. And you can put that anywhere you like. This Pulsar staging dir variable defaults to our Pulsar root /staging or /file/staging. And then the persistence directory. Occasionally we can ask Pulsar to hold on to files for us and say, actually, this is not just a temporary job file, but this is more of a permanent file. And can you store this in the persistent files directory? And that'll be under Pulsar root /files/persistent. And then we need to specify a tool dependency directory, i.e. where Pulsar should install tools to using either Conda or Singularity or Docker. And then we need to set a whole bunch of things about how Pulsar will talk to our Rabbit server, our queue server. So what Pulsar needs to monitor so that it knows when it has jobs. And we do that by using the Python AMQP protocol. And we set the user that we want to have, which is Galaxy AU. We grab our password for our user. And then we send that to our Galaxy server hostname, because that's where our, which is up at the top of this file. Now scrolling doesn't work. So this machine here, and we're looking at that machine on port 5671, which is the one that the Rabbit and Q servers are sitting on. And we need a double slash here because the name of the virtual host is actually /Pulsar/Galaxy AU. And so that's the queue that we want to talk to. So we need a // here, so it's not a mistake. And then we also want to set the SSL to be 1 so that everybody knows that we're talking encryptedly. That was a strange word, encryptedly. Anyway, and then we need to set a few AMQP different things. So we want to say that minimum polling interval is about 0.5 seconds. So every half second, just go and talk to the queue and see if there's anything there for us. Now, these ones are every time we send a message to the queue, just in case there's network issues over the internet, we want to retry it to make sure that the message queuing or the message actually gets through to the message server. And we want to retry 5 times, we'll wait 10 seconds or so, and every time it fails, we'll wait an extra 10 seconds. So the first time it fails, we'll wait 10 seconds. The second time it fails, we'll wait 20, etc., all the way up to 60. And so basically, this is just a bit of security to know that hopefully our remote server will be able to talk to our message queuing in case something goes wrong with the internet. And then lastly, we need to tell Pulsar how to resolve dependencies. Now, just like in Galaxy, we can set how Galaxy looks for tools and installs the dependencies of those tools. And in our case, we're going to tell Pulsar to install all of its tools using Conda. And we want the auto init and auto install to be true. So this basically says that if Conda isn't installed, please install it. And this one says, if the tool isn't installed and we need it, please install it. All right, and now we need a couple of other lines we need to add. These 3. So copy. Go to the bottom and paste. And this particular line basically just says that we would like our Pulsar to collect the job metrics, i.e. how much CPU we used, how much RAM we used, how long the job ran for, and send that back to Galaxy as well as the rest of the job metadata and the job output data. And this is just so Galaxy can collect all of that information that you can then use for monitoring. You can use to do troubleshooting if you're an administrator about jobs that overran their memory requirements or whatever. And so this is really handy information to have. Okay, so that's done. We're going to save and close that file. Now, obviously we're using Conda here to do our dependency resolution, but we can do non-Conda tools. So if it's a tool that isn't in Conda or Singularity or Docker, we'll need to make sure it's installed locally on the Pulsar server and available on the path that Pulsar can see. And so there's a lot of documentation about how to do that, but it's a little bit beyond our scope for this particular tutorial, but the Pulsar documentation is very well written and has a lot of information about how to do this. All right, so now we need to tell Ansible about our Pulsar server. So we have a Galaxy server that we've been running all of our Ansible on, but we've been using the local connection to do that. But in this case, we're going to run our Ansible from our Galaxy server, but we're going to make modifications to our Pulsar server, which is remote. And so we need to tell our Ansible where to find that particular machine. And so we do that in our host file, and we're going to create a new group called Pulsar servers, and we're going to add the fully qualified domain name for our Pulsar server, which won't be cat-0, it'll be whatever yours happens to be. And then we'll set the Ansible user to be Ubuntu. Okay, so let's look in our host file. And as you can see here, we have our Galaxy server, and mine's GAT8. Yours will be different. And my Ansible connection is local. My Ansible user is Ubuntu. We want to add a new line to this. We want to add a group called Pulsar servers. And now we need to tell Ansible which machine. So if I go back to the spreadsheet up here that has a list of all the machines, the one that's been assigned to me is GAT-7. And so I'll copy that and I'll paste it here. And then we don't need to say the Ansible connection is local because it isn't. And by default, Ansible will try to talk to a machine over the internet, which is what we want to do here. So we leave this out, but we do want to say that the Ansible user is Ubuntu. So I'll copy that and paste it here. Okay, hopefully that makes sense to everybody. So now in our host file, our Ansible can talk to 2 different machines depending on which playbook we run. In our for our Galaxy server, we want to talk to this particular machine over the local host connection, but for our Pulsar server, we want to talk to this particular machine over the internet. Right, so I'll close that. Go back to our tutorial here. And we're going to write a new playbook for the Pulsar installation because we're going to install on a separate VM. So we're not going to be talking to our Galaxy server to install Pulsar on. We're going to install on a remote machine. And so we need to write a new playbook for that and point it to a different host. All right, so we're going to create a new playbook called pulsar.yaml. .yaml, not -yaml, BIM pulsar.yaml. And we're going to cut and paste all of this here into it. And then we'll talk about everything that's happening here. Okay, so this is an Ansible playbook, which hopefully you've seen a couple of times so far this week. This playbook says, we please do all of this stuff on our things that are in our host file under the group Pulsar servers. And if you remember in our host file, we've defined this group and we've also told it where to find which machine is our Pulsar machine. And apart from opening the Pulsar servers.yaml group class file, we also need to look in the secret.yaml file because we need to get the passwords out of here. And so we define that by saying var files and then adding it in. Now we want to install some pre-tasks because this particular machine may just be a brand new spun up cloud image, or it could be a machine somewhere that's just running vanilla Ubuntu, and it may not have the required apt packages or yum packages installed on it. And so we need to install some packages on this machine before we can do anything to it. So the first one we need to install is build essential, which basically just lets us compile stuff. We need to install Git. We need to install the development version of Python 3, so we get all the dev headers. libcurl 4 with the OpenSSL bindings. We need to install libSSL, and we need to install Python virtualenv. We need to make sure all of them are present, but before we do any of that, we really want to update all the cache, which is the equivalent in Ubuntu of saying sudo apt update before we try to install anything. And we're going to need to do this as the root user, so we will become yes. So now once we've configured all of our pre-tasks, then we can just run roles. And you'll notice there's 2 roles here. We're not just running Galaxy Project Pulsar, but we're also running Galaxy Project.cvmfs. And you think, hang on a minute, we've installed CVMFS on our Galaxy server. Why the hell do we need it on Pulsar? Well, if you think about it, sometimes Galaxy may ask Pulsar to do something that requires a reference file. Now, if we're lucky enough and that reference file is located in CVMFS, that means Galaxy doesn't need to transfer the reference file down to Pulsar because it may already exist on the Pulsar file in the CVMFS repo. So if you've done the CVMFS tutorial and you understand how CVMFS works, and you know that all the Galaxy reference data and reference indices for all of our different tools are all installed in that CVMFS repository. If we install that on our Pulsar server, the Pulsar server will then have access to all the same reference data material that our Galaxy server does. And so when our Galaxy server says, please map all of these reads versus the human genome, it doesn't need to transfer the human genome down to the Pulsar server because they already exist on the Pulsar server in the CVMFS repo. And this is actually a really powerful thing because we can add this CVMFS repo to any machine we like and all of those machines will have access to the Galaxy reference data. And then obviously we need to install Pulsar using our Galaxy Project Pulsar Ansible role, which is all that configuration we did in our Pulsar servers.yaml group bars file. Okay, let's close this and save it. And now we're going to run the playbook. And this one may look a little bit different. Now, Ansible uses SSH to talk to remote machines. So just before we do this, there's a couple of little things. So Ansible is going to use SSH to talk to a remote machine. Now, we have a username and password for that particular machine, but Ansible can't use usernames and passwords to talk to remote machines. It really needs to use SSH keys. Now, luckily for us, the people who set up our machines for us installed a key onto our remote machines in the authorized keys. And within our Galaxy servers, we also have a key. We have the private key for that particular remote host. If we go up and look at our user directory, you can see here in our .ssh. And if we look into .ssh, you can see here that we have this private key called ID_RSA. And inside that file there is the private key that will let us connect via SSH to our remote Pulsar server. So this is something that you may need to set up if you are doing this in production or you're setting up your own Pulsar server. You will need to have the ability for the Ansible to talk to that Pulsar server using SSH keys. All right, go back to our Galaxy, and now we're going to run our Pulsar.yaml playbook. So we go Ansible-playbook, Pulsar.yaml. Now remember, this is talking to a different machine over the internet. We're no longer running Ansible over a local connection. Right, so my remote machine has installed some packages. It's installing CVMFS, which is wonderful. Now we're installing Pulsar. So we've created the root directory. You'll notice here we've created dependencies and the persisted data and the staging data and the config directories. We've created the virtual environment, and now we're installing Pulsar using pip. And now we're installing all the dependencies. Remember, they were Kombu, PyCurl, PyOpenSSL, and all those other dependencies. Okay, so our playbook is now complete. You can see here that we've installed Pulsar, got it all running, and you can see we've added some Pulsar configuration files, server.ini and localenv.h. This localenv.h file just contains where the drama library is, and this one here contains information about how to start the system up. So I suggest probably what we should do now is connect to our Pulsar machines and go and have a look and see what it actually installed. So I'm going to open up a new tab in my terminal. I'm going to increase, and you can all have a look and see what Chuck Norris is doing. I'll clear the screen, and now I'm going to SSH to training Galaxy project.eu, and you'll notice that this is GAT7 because that's my Pulsar machine, and the password is here. Okay, so now if we have a look in here, there'll be nothing in our root directory and our home directory. But if we go to cd/mount, can see that we have Pulsar installed. Let's have a look at what's in Pulsar. Right, we have config, deps, files, and venv. All right, so in our config, we have app.yaml, job metrics conf, local env.sh, and server.ini. Let's have a look inside each of these files and see what is in there. App.yaml, you can see here we have information about how we're going to go about connecting to our queue server. So we have the message queue URL, and we've put in that long line that tells Pulsar how to connect to the queue server. We have our job metrics conf file, which we're all set up for us, which contains information about all the different metrics we want to grab, which is exactly the same as the ones we have configured for Galaxy. How we want to do our dependency resolution. We have some retry information about connecting to the queue server. You can see here about the polling interval, and then we have some settings that will say where our persisted data is, where our staging data is, and where our dependencies are installed. And so if we go back to here again, we can see deps. So let's get out of there and go and have a look and see what's in deps. And you can see in deps we have Conda installed. That's pretty cool. And let's have a look and see what's in files. You can see we've got persisted data and staging. Staging is where the job working directories are going to go, and persisted data is where any persistent data will end up if we want to cache any particular data on our Pulsar server. And venv contains the virtual environment that Pulsar runs from. We can look at the log for Pulsar by doing journal ctl -fu Pulsar. And you can see here the end of the log from Pulsar, but basically you can see here we've updated Conda, that's installed Conda and updated it. You can also see down here that it has done a bunch of connections to the queue server on GAT8 on that particular port, and it's connecting to that vhost. And you can see here that the AMQP heartbeat is alive, which means that it's actively talking to our queue server in Galaxy and saying, hey, have you got any jobs for me? No, there's nothing there yet. Is there any jobs for me? No, nothing there yet. And it's doing that every 0.5 seconds. Right, that's really cool. Let's close that. Let's go back to here. So we've looked inside our Pulsar directory. If you had connection issues, click on this box here. We may need to specify, if you haven't used the default private key that we set up for you and you're using your own, you may need to set the --private -key option in your Ansible playbook command and then give it the name of the private key that the public key is on your Pulsar machine. All right, so far what we've done is we've installed a Rabbit server onto our Galaxy computer, and if we scroll all the way back up to the top of our little diagram, we've installed this, and we've set up this Pulsar queue, and now we've installed Pulsar in queue mode on our remote resource, compute resource, and we've told it to communicate with this queue, which is fantastic. And so the step we're up to now is telling Galaxy how to talk to the queue server so that the queue server can then relay that information onto the Pulsar remote resource, and the remote resource can then run the jobs for us and then send the results back to Galaxy server for us. So the only thing we really need to modify in Galaxy is the job conf, because Galaxy is just going to run like normal. All we need to do is tell Galaxy how to connect to the queue server, and then tell Galaxy about the destination, a little bit about the Pulsar server so it knows how to handle certain types of jobs. All right, and then we need to tell Galaxy which jobs to send to the Pulsar destination. And so if you've done the connecting to a compute cluster tutorial, you should know all about how the job conf.xml file is configured. But we'll scroll down to where we're up to now. Oh, not testing Pulsar. There we go. Configuring Galaxy to use Pulsar as a job destination. Right, so as I just mentioned, we need to edit the job conf file, and we need to tell Galaxy to load a new piece of code called the Pulsar MQ job runner. And this is Python code that will allow Galaxy to connect to the Q server. And then we need to tell Galaxy how to go about using it. So we're going to edit the job conf file and do all that. So the job conf file is a template, and remember it's in templates, Galaxy config job conf.xml.j2. So then we go to vim templates, Galaxy config job conf.xml.j2. And if you remember, this file has a plugin section, a destination section, a resources and tools section, and sometimes a limit section as well. But the thing we're going to concentrate on now is the plugin section. We're going to add a new plugin. We're going to tell Galaxy to load the Pulsar job running code. And then we're going to define a Pulsar destination. And the Pulsar destination definition will allow Galaxy to send jobs to the Pulsar. All right. So we go all the way to the top of this file. Don't use the mouse. I haven't got mouse configured. All right, so go to here, and we need to add in a new plugin. Right, so I need to add in this plugin here. So I'm just going to copy and paste this entire green section, and then I'll copy it into here and then talk about what it all does. So paste it here. So we've pasted in a new plugin. All right, this is a bit different to the other plugins, and I'll explain why as we go. So the idea of this plugin that we've just installed is Pulsar_runner. It's of type runner, and we want it to load galaxy.jobs.runners.pulsar Pulsar MQ job runner. And now basically this is just a piece of Python code that tells Galaxy how to connect to the message queue and what to send it. And now obviously we need to tell Galaxy how to find the message queue. And so we give it an AMQP URL, and we set that to the same URL that we set up in our Pulsar server. So in other words, except in this case, we're sending it to localhost instead of the fully qualified domain name, and we're still sending it to 5671. And the Python AMQP, the username is Galaxy AU. We're pulling the password out of the vault again, and we're sending it to the vhost, the vhost that we set up before, and we're saying please use encryption. And then we've got a few parameters here, republish time, acknowledgement, consumer timeouts, etc., that basically tell Galaxy, you know, if something fails and you can't talk to the Q server, then try again. Please acknowledge that you've got messages so the Q server knows that you've got the messages. You know, if you're trying to send a message and you can't get back to it, then, you know, try again a few times. And then this one here is important, the Galaxy URL. And this is basically passed to the Q server. It is also then passed on to the Pulsar server, saying where Pulsar can find the Galaxy server. Okay, so sure, Galaxy can talk to the Q, and then the Q talks to the Pulsar server, but Pulsar needs to know how to talk to Galaxy so that it can curl the files in and out of Galaxy. And so that's why it needs to know what the URL of the Galaxy server is. And then we're going to say manager default, and this basically just means please send it to the default job manager on the Pulsar server. So the job manager is very similar to the job conf in Galaxy. It's the file that it's the destination in the Pulsar server that we're sending it to. In this case, it's just a local queue. Now, if the Pulsar server was a big cluster or a Slurm cluster or a Condor cluster, then we could specify in Pulsar what this default means and how many CPUs to give it, which queue to send it to, etc., etc. But at the moment, we're just going to use the default destination, and it's just a local runner. Okay, so we've set up our plugin. So Galaxy knows how to contact the Q server, and now we need to define a job destination based upon this runner. And so we go down to our destination section, which is directly below, and we'll add one in just after the local plugin, the local destination. We'll add it in here. And this one, we need to add in this section here, which is Pulsar destination, which is based upon the Pulsar runner. And this one is actually quite long as well and has a few different things we need to include. And so I'll just copy and paste it into our file and then talk about it. Cut. Paste. So now we have a new destination in our job conf file. It's called Pulsar. So the destination is called Pulsar. It's based upon the Pulsar runner, which means that every time we send a job to here, it's going to send it out via this message queuing system. And now we need to tell Galaxy a little bit about how this job's going to be handled. Now, this one's important, the default file action. So basically what we're specifying here is that how we want the file transfer between Galaxy and the Pulsar server to be handled. And we want it to be done by remote transfer. In other words, we want the Pulsar server to look after all the file transfers. All right, so instead of Galaxy pushing files to the Pulsar server, we want the Pulsar server to pull files from Galaxy. Dependency resolution is set to remote so that Pulsar server knows to do its own dependency resolution. The jobs directory, in other words, where do the jobs run, or where the job temporary files kept on the Pulsar server, and it's in /mount/pulsar/file/staging. Any persistent data, any data that we cache on the Pulsar server will be kept in persistent data. Remote metadata is set to false. In other words, basically we want Galaxy to handle the job metadata creation and updating the database. We don't want Pulsar to be doing it for us. We want it to be done by the Galaxy server. We want to rewrite the parameters. We've set that to true. And that basically just means that when Galaxy produces the command line for a tool and sends it off to the job, that all the paths in that job command will be rewritten to match the local Pulsar file system and not still have the Galaxy file system in there, which is, you know, we need to be able to do. And then the transport, how do we want the files to be transported? Well, we need to tell Galaxy that we're going to use curl from the remote system to pull the files in and to push them out. Okay, and then outputs to working directory false, and we basically set this one so that Galaxy knows that not to try and pull the results from the local working directory, but instead that Pulsar will be sending them directly back to Galaxy's file store. All right, so there's quite a lot of information in that job destination, and all of these parameters are actually really important. And there's a lot of documentation that comes with Pulsar that explains them all. Hopefully I've given you a good understanding of what these all do today though. Okay. There's a bit more of an explanation about outputs to working directories. There's a tip box here about installing BWA and BWAMM tools on our Galaxy servers. So before we can send jobs to Pulsar, we need to have some tools installed on our Galaxy server so that we can run jobs and so that we can send those jobs to the Pulsar server. So I'm going to go to my Galaxy server here. Look, I've already got BWA installed. But basically we need to make sure that BWA and BWAMM are installed so that we can then tell Galaxy to send those jobs to the Pulsar server. And the way we do that is we go to our Galaxy server. So this is mine, GAT8. Yours will be whatever your one is. I'm logged in as an admin user, which hopefully you are too. Therefore, I can click on the admin menu. Okay. The certificate must have been updated. All right, so here I am. And now I want to go to install and uninstall. So click on that. And I want to search for BWA. And there's BWA, so click on that. You can see here that I have actually installed it because it's red and it says uninstall. So if I click on this button, then it would uninstall it. Yours may have a blue button that says install. If it does, please click install. And then it'll ask you where you want to put it and just say mapping or something like that. The details on how to do this are actually written down inside this tip box here. Okay, right. So hopefully now everyone has the BWA tools installed on their Galaxy servers. And the way you can check that is by going to the tool search and typing in BWA, and you should see BWA, a map with BWA, and map with BWA mem. Hopefully you have those there. All right. Now we need to tell Galaxy what to do every time one of those tools is run. And so in the tools section of the job conf file, you may remember that we can specify different tools and destinations for those tools. And so that's what we're going to do here. We're going to specify that the BWA and BWA mem tools both get sent to the Pulsar destination. So we go back to our job conf file, we go all the way to the bottom, and here we have our tools section. We're going to add a new one to the end. We're going to add these two. Cut and paste. So basically we're saying every time BWA is run, please send it to Pulsar. And every time BWA mem is run, please also send that to Pulsar. All right, so now we're going to save and quit. Now the only thing left to do is copy the new job conf file across to Galaxy and restart it. And the way we do that is by running the Ansible playbook again. However, there's actually a mistake in here. It says here to run the Pulsar playbook. Well, that won't work. So we need to run the Galaxy server. Hopefully before you guys do that, I'll have actually fixed this so that it says Galaxy, not Pulsar here, and you'll actually be running the Galaxy one. So hopefully you won't see that. In case you do, in case you're still looking at an older version of the tutorial, please make sure that you run the galaxy.yaml. All right, so we're going to go Ansible playbook galaxy.yaml because we want to update the job conf from the Galaxy server. So this should run fairly quickly, and the only thing it should change is it should only change the job conf file. So you'll notice that as we've gone throughout the week, this playbook has got longer and longer and longer, and it's done more and more and more things. That's actually pretty cool, because what we've done is we've slowly over time built up our complete Galaxy server configuration in one Ansible playbook, which means if it ever dies and you need to restart, what you need to do is run the playbook and everything comes back. It's actually pretty cool. We're getting there. You can see here it's restarting Galaxy, and it's complete. Okay, so all that's left to do now is test Pulsar. Okay, so it says we want to run our job on Galaxy to make sure that our jobs get sent to Pulsar. So the first thing we're going to do is upload a couple of files to our Galaxy server. I'll just copy that and go to Galaxy, click on upload files, paste fetch data from the URL, paste them in, and change the file type to FastQ Sanger, because that's what they are. And if you're wondering why we're doing that, then just go and do some tutorials on read mapping and variant calling. But basically, FastQ Sanger is the file type that we want to set these to. Start. and close. And so basically now our Galaxy server is running a job. That's running an upload job, which will be run locally. And then these two files will be uploaded. And you can see here that they are. All right, we're done. Fantastic. What do we want to do next? We want to run map with BWAMEM. And we want to map them against Escherichia coli. But it'd be a really good idea to watch what's going on the Pulsar server and on the Galaxy server at the same time. And so what I'm going to do is I'm going to load, I'm going to follow the journal, the Galaxy journal on the Galaxy server and the Pulsar journal on the Pulsar server and watch the log files so that when we actually run this job, we can see what happens. Okay, so I'm going to go journal CTL -fu Galaxy here. You can see here's my Galaxy log. I'll go back to my Pulsar server over here, and I still have the Pulsar log running, which is great. All right, let's run this job. We'll go to my Galaxy server. I'm going to run map with BWAMEM. I'm going to use a built-in genome index. I'm going to search for Escherichia coli. I'm going to use paired end reads. I'm going to select the mutant R1 for the forward reads, or the first set of reads, and mutant R2 for the second set. Scroll down to the bottom and click execute. Now, what should happen is Galaxy here should say that it's sending the job off to the Pulsar destination, and on the Pulsar server, when we go and look at its log, it should say that there is a new job for it. So let's click execute. You can see here, job runners, handlers, etc. And where's it gone to? Job's been dispatched. All right, let's go and have a look over here. And you can see here that now the Pulsar manager has picked up the fact that it's been given a job. Okay, and so it says, checking the authorization of the command line. Oh, hang on a minute, it's executing a command. And it says it's realized that it doesn't have BWA or SAM tools installed, and so it is using Conda to install that tool. That's pretty cool because it knows we want to run BWAMEM, and therefore it knows that it needs to install a whole bunch of stuff. So it's using Conda to do that, and now it's finished, and now it can run the job. And so it's sending a thing back to the AMQP server saying that the job is being updated, the status is updated. And you can see now that our job's gone orange, and now the job's complete. And it's actually sent another status update back to the Q server. And then if we go to the Galaxy log, you should see Galaxy has noticed that the job is finished. And if we go to here, it's green. Fantastic. So I'm not sure if you understand the power of what we've just done. But basically what we did was we took a remote computer, and it could have been anywhere in the world. It could have been anywhere in the world. A remote computer, we installed Pulsar on it. We told Galaxy how to connect to it via a message queue server, and then told Galaxy to run a job. And then the message queue server sent that job off to the Pulsar server somewhere else in the world. That Pulsar server ran the job for us, installed the correct tool, ran the job, and sent the results back to our Galaxy server. And if we have a look in our BAM file, you can see here we have the BAM file. Fantastic. Okay, so it all works. That's pretty good. Now, if you've failed to keep up or something went wrong, you can compare anything that we've done today against the reference files. So in other words, the finished, polished files for the Ansible stuff, and anything that changed since you've done the previous tutorial. You can click on this link and it will show you the differences that you should have had in your version of the files. Now, sometimes Pulsar and Galaxy fail to talk to the Q server. Okay, and so that's why we've been setting all of these max retries, start and stops, etc., etc. And we need to do it, sometimes we need to do it for the pre-process and for the post-process. So pre-process means, hey, yes, I've sent some stuff, but post-process is when Pulsar is trying to send the files back and it needs Galaxy to accept them. It needs to be able to do that a few times sometimes. And so setting these kind of parameters in our Pulsar setup will help sometimes. Okay, now I just want to quickly talk a little bit about Pulsar in production. If you want Pulsar to make use of a supercomputer or a large cluster at the Pulsar end, you only need access to a submit node or the ability to send jobs to a Slurm queue or a Condor queue or a PBS store queue or whatever you happen to be using at your institution. We recommend that you run the setup with Pulsar, that we deploy an AMQP server somewhere. Preferably put the AMQP server next to your Galaxy server. And obviously the Pulsar, you just need to install that into user space on your remote host somewhere. And then for each new Pulsar server, so sometimes you may want to have more than one Pulsar server, and for each one, you'll need a separate vhost. And then you'll also need a separate user to connect to that separate vhost. And in the Galaxy job conf file, for each new Pulsar server, you'll need a new job runner with the new connection string. Okay, so you can't just reuse the job runners again because the job runner contains information about which queue to talk to. So we need a new job runner, and then we also need new destinations based upon that new runner. Okay, so Pulsar service can be the head node of a cluster. We can use Slurm or PBS or to schedule jobs or Condor or anything like that. We can change destinations. We can change the number of CPUs in our destinations, and the amount of RAM that can be used. It can get really complicated and quite flexible. In Australia, we run about 5 different Pulsar servers spread out all around the country. This is a little bit out of date now, but we have quite a few more than this now. But they all communicate with our Galaxy server via one RabbitMQ server. So we have one RabbitMQ server, one Galaxy server, multiple Pulsars. We have multiple queues in our RabbitMQ server, and all the Pulsars communicate with Galaxy via that RabbitMQ server. In Europe, they do something very similar, except for the fact that they have a much larger Pulsar network spread out all across Europe. And they even have an international connection down to a Pulsar server sitting in Melbourne, where I'm from. And the main purpose of Europe of doing this is so they can distribute the load. So they have quite a large load, a large number of jobs running on my Galaxy server here in Australia and the Galaxy server in Europe. And so we want to spread the load out. We want to not just use all one computer all the time. And so we can with Pulsar. It's really wonderful. All right. So hopefully you realize that the key points are that Pulsar allows you to send jobs to anywhere in the world, and it also works well in a situation where the compute resources cannot share storage. Okay, if you have any frequently asked questions, you might be able to find out here. Remember, the Pulsar documentation is quite thorough and really good. Could you also click on this link here, fill in the feedback form, tell us what you liked about this tutorial, what you didn't like about this tutorial, as that helps us improve our material. And if you use this tutorial and to build up your own Galaxy server and Galaxy Pulsar network, then can you please cite this tutorial whenever you publish your results. Thank you and congratulations on successfully completing the tutorial, and goodbye.